Great. Warm welcome to an exclusive episode of BSc Se Kya Hoga, the Science Unlocked series from the stable of the Monday Morning Learning podcast. Now, in 1987, one student topped the JEE, All India Rank 1. Every parent in India would have mapped out the next move, computer science, electronics, the safe streams. But he chose physics. He joined the integrated MSc program in physics at IIT Kanpur and never looked back. He went on to do his PhD at Princeton University. After research associateship at Harvard, he spent years at the Harish Chandra Research Institute and was a long-time visiting member of the Institute for Advanced Study in Princeton. His work on simplified version of string theory led to the discovery with Cumrun Vafa of the Gopakumar-Vafa duality and the Gopakumar-Vafa invariance, results that now carry his name in the international physics literature. He is a recipient of the Shanti Swarup Bhatnagar Award, the ICTP Prize in honor of W.C. Wick, the Swarna Jayanti Fellowship, the J.C. Bose Fellowship, the G.D. Birla Prize, the TWAS Prize in the Physical Sciences. He is a Fellow of the Indian Academy of Sciences, the Indian National Science Academy, and the National Academy of Sciences, India. Today, he serves as Distinguished Professor and Director of the International Center for Theoretical Sciences, ICTS-TIFR, in Bengaluru, one of the finest theoretical sciences institutions in Asia. All of this because he chose physics. And when I shared the post on BSc Se Kya Hoga, Professor Rajesh Gopakumar, our esteemed guest, wrote back with something that stopped me cold. He said the fact that this question is asked at all reveals a societal flaw, one that weakens our country's capabilities. It's not a personal regret, but a national diagnosis. So today we are going to have that conversation. Welcome on board to Science Unlocked, Professor Rajesh Gopakumar, and thank you for being here. Any welcome words before we start off?
Thank you very much, Ravi, for that very kind, generous introduction. Happy to be here and happy to know about your podcast efforts to get more people into the basic sciences and create kind of a change in the mindset of society. So happy to be part of it.
Great. Thank you. Thank you. It's a privilege to have you on the podcast, Rajesh, as I said earlier. So we got 5 themes, something which I've shared with you. So we'll start off with the moment of choice, couple of questions. Then we'll move to the learning journey. Then we'll look at science, society, and the Indian context. Also questions around building ICTS-TFR. And for the next generation, couple of questions over there. And if time permits, as I said, we have a few more questions for you. So we'll start off with the moment of choice theme. You topped JEE in 1987 and chose physics at Kanpur, IIT Kanpur over engineering. What was going on inside you at that moment? Was it clear conviction or was it doubt and external pressure, Rajesh?
Yeah, it was I mean, it wasn't that there was a moment of choice at that moment. I think I think it was sometime in class 10 or something when I had decided that I would do some combination of physics and mathematics. And I had told my parents I wouldn't be doing engineering, whatever my parents were. My father was working in the government service, and we had a lot of colleagues. We used to live in government service quarters. There were people, my peers, they were all mostly going in for medicine and engineering. But I think I had discovered mathematics, I had discovered physics, and I felt that my life's calling was to sort of explore those. I mean, it was, and I didn't have any. I mean, I just so and I was more. The more I learned, the more I was fascinated, and I felt this is what my lifetime spent in this will be, I think, worth living. And I call myself a bit of an accidental IITian because of this, I was not actually thinking of going to the IITs or anything. I didn't know very much except that there were engineering places. So I had some very good friends in the same year, and they were preparing with Agarwal and Brilliant. There were these coaching classes at the time, but I had set myself the goal after my class 10 exams to study physics and maths. I think I had a somewhat of a reasonable picture of things to do, and I just had some good books, and I said, I'll just work through them. I'm not going to worry so much about school or anything. I'll just join a BSc program and study physics. But then there were also problems with the BSc, the very good colleges in Kolkata where I was growing up. There were problems with the exams, and there were so people sort of saying that that may not be the best place. And at the same time, when I was in class 11, someone a year senior to me had gone to, a good friend had gone to IIT Kanpur and had written to me that, you're interested in physics. This place has a great physics program. It has some wonderful teachers, and it's really very nice. He Xeroxed at that time for me the course book of all the courses taught by the physics department and the list of the faculty, and it sounded very attractive. So I thought, okay, I'll give the exam and keep that also as an option. And then I mean, I think I prepared a bit before for the chemistry parts, which I had not been paying that much attention to. And I think, I mean, yeah, so in a sense, the moment of choice was never there at the time. I mean, the results came, the results were whatever they were, but that didn't affect my decision because there was one that was not contingent on the particular rank or outcome of the exam. So to me, it was just natural that I just continued to do what I had set my mind to do.
Great, Rajesh. Thank you. So after getting the rank AR1, the BSc Se Kya Hoga was a question directed to you personally. So can you actually reveal who asked it, or who all actually asked it? What was the emotional texture of that moment, and how did you respond? That's one. And what gave you the inner anchoring to hold your course despite what society was signaling? I think you touched upon it, but if you can expand on
Uh, Yeah, I mean, my parents were supportive. I mean, they asked me, "Are you sure?" I mean, and everything. I said, "Yeah, I'm sure." And but they were supportive, and I think because I had told them already a couple of years ago, so they were mentally adjusted to the fact that okay, he'll do something, he'll find his way. But I think there were people like this. You have a circle of people, fairly the usual middle class Indian society for people. Of course, I was taking an MSc program, so they didn't really ask me BSc, but they said, "What will you do with a 5-year MSc? You'll just become a school teacher or some college teacher or something. I mean, is that what you want?" And I mean, so people ask me all those things. But I mean, for me, actually, even the life of a college teacher or school teacher wouldn't have been very bad even. So it didn't matter to me. I think if they said if that's what the thing, as long as I have the opportunity to study these subjects that I enjoyed, that was what was most important to me. And I think I had learned long ago to ignore most things that people say. I think, and just trust my own inner compass. So I think that was maybe what helped. And Yeah, so I won't say it was some inordinate pressure, but okay, yeah, it's the kind of things people. I mean, they're probably concerned about you, and they want to make sure that you've made these decisions with this thing. I think, and people probably realized that I had made these decisions with some amount of thought, and it was not some whim. And Yeah, but when I went to IIT Kanpur, also, I think there people were some people were almost very upset. I think that I had not. It was almost like yeah. Anyway, I think they kept asking me in a way I think they wouldn't have ever asked someone who took computer science, "Why did you take computer science?" I mean, no one asks them why they have to take computer science. Why do they ask me why I'm taking physics? I mean, I enjoy it, I like it, and So I used to be a little flippant. I think, in the beginning, the seniors would catch you and ask you, and I would just say, oh, yeah, I'll just give it a try, I thought. And then that also bothered a lot of people, I think. But
Great.
yeah.
So one of the questions, Rajesh, I'm asking professors, especially in this profession, are any traits that parents or students can actually identify in themselves that can actually lead to this kind of career, so a pure sciences kind of career. And what I really loved about your response was you had a very strong inner compass, right? That's what that was very, very clear. And you also said on the statement that what others said doesn't really matter because you're pretty clear in terms of what you wanted. So any kind of traits which you can actually list or which you observed in terms of people really loving the subject and wanting to go through it. So can you actually share?
Yeah, I think, I mean, I didn't know, of course, very much about the texture of a life in science at that time. I had I had read, I had actually access to the National Library, which was a very great resource, and I had read many popular books and all that, but that was the extent. I didn't know anyone in my family or extended circle who was a professor or an academic in the sciences. So I didn't really know what traits one really needed to have. But maybe in hindsight, I can say you definitely need curiosity, the ability, the desire to ask questions, a sense of wonder at the universe, and perhaps not not too much of worrying uh, about immediate gains and not viewing life as some kind of calculation of cost and benefit. And I think perhaps it's a I mean, I do think that you need to have certain traits of tenacity and being willing to stay the course and see the long view, take the long view, or play the long game, as they say. And not, you won't, in research is very uncertain by its very nature. It's You have to be prepared for that uncertainty. You have to be prepared to be defeated many times by the difficulties of the problems you're attacking, and that knowing that progress is slow, progress is sometimes you're stuck and you can be demoralized in many ways. You have to have a certain mental toughness, I think, to overcome some of that. I think there was a quote I liked by a writer who said about writing that to be a writer is to be defeated by bigger and bigger things. Something to that effect. I may not be quoting it exactly, but in some sense, it's a bit like that. For a life in science, it's the bigger and bigger things that as you grow, what you are challenging is, I mean, you're trying to decipher nature, which, if you think about it, is an act of incredible hubris. And so the chances of your being defeated are very high, but you nevertheless persist. And I think that's the kind of a romantic image of the human against the human trying to make sense of the cosmos that they are part of, whether it's the physical cosmos or the mathematical cosmos or the biological cosmos. I mean, I think in science you have that. So I think someone has traits which sort of I think, have that passion and that kind of burning desire. I would say, yeah, that's very necessary to be able uh, uh, to continue in a life of science.
Sure. Sure, Rajesh. Thank you. So moving to your learning journey, Rajesh, what did IIT Kanpur's physics program give you that you believe no other path in India at that time could have?
Yeah, it was very fortunate that in some ways that I took the physics program at IIT Kanpur. I'm very grateful to my teachers there, and and a small band of us who had all taken physics because we enjoyed it. I mean, so I sometimes think, I mean, many people ask me, okay, I mean, I I think there are many bright people who were taking physics at that time as well. Maybe no one had this AIR rank, but that doesn't mean much in some sense. I mean, it's one exam, one thing you give on some particular day, and it turns out you win the lottery or some sense. But I mean that. I think the people in India, we overinflate the importance of these exams, and we think of them as some great verdict on our intelligence or something. But I really do think that it's very overinflated. So in any case, there are brilliant people and of all kinds, people who do well in exams, people who don't do well in exams, but there are all of them, and we had some very good people in our physics. In our year in physics and also some of the other departments. And I think learning the subject together with them and from these teachers who mentored you very in a very selfless way. I think the generation of teachers we had at that time was still many of them from the early days of the IITs. So they had all returned to India after doing very well in their studies and getting their doctorates from prestigious places and coming back to India with a sense of mission, with a kind of a mission that I think imbued post-independence India, and where they felt they were building the IIT for the future, for the country. And so that sense, I think, was still there. And the teachers, I think the way they were mentoring us, they introduced us to the best possible pathways to learning the subject. Some of their courses were just amazing. I wouldn't miss a single class of some of those courses. It would kind of really give you a high after attending some of those lectures. And then even outside the lecture halls, they would talk to you over coffee. It was a very non-hierarchical kind of environment, and I think I really enjoyed that. Uh,
Perfect, perfect, Rajesh. So from IIT Kanpur to Princeton PhD to Harvard Research Associate to IAS Princeton, how did each transition shape your thinking as a scientist and as a person, Rajesh?
Yeah, I mean, it is, these are in some sense different stages in one's evolution. And and I think the toughest is the transition from being a student to being a researcher, because then it's not just you leave behind this idea of just kind of mastering some material and doing well in some exams or and essentially doing things that others have done before you. You're just redoing them to a stage where you have to discover something new. You have to, as I said, start being defeated by bigger things, and so you that's very difficult. I mean, as you can imagine, psychologically, and it is. I mean, it's something which not everyone I think is cut out for that, and which is one reason I say that these exams and everything don't mean very much in the end, because in the end it is that mental toughness that ability to ask questions, the right questions, develop a sense of judgment, the willingness to work very hard at something and be willing to pursue it even when one is stuck, and the ability to know which problems are probably tackleable. Of course, your advisor, and I had a fantastic PhD advisor who help you in that process. They are kind of your gurus, and they kind of guide you into that. But nevertheless, it is difficult. There are moments of self-doubt and moments of when you feel, yeah, maybe you're not cut out for this and so on. It's, I think, a natural feeling. And so I think that transition in Princeton was an important one to go through. And Princeton had, at that time, fairly hands-off attitude. They didn't ask people to take courses. They just had some qualifying exam which you had to get through, in which you had to essentially master all of physics. I mean, and they had like two sets of like 10 different papers, and they were very good questions, very creative questions set by some of these fantastic researchers.
Mm.
And you had a great cohort of students. I mean, that's one thing that when you're that you realize the Princeton at that time was attracting the best students from across the world.
Mm.
There were, out of our 18-year students who joined in the first year for physics in my year, there were only 8 who were Americans, and 10 of us were from outside the US, and so it was very international that way. And then you make these other new friendships, and it was also a culture shock. I had never been out of the country before that,
Mm.
and going to the US in the 1990s from pre-liberalization India
Mm.
to the US was a big culture shock as well. But yes, you navigate all that. And then after your PhD, as the postdoctoral experience is also very valuable. You've begun to find your way as a researcher. You're still groping. I mean, you're always groping in research, but you
Mm.
you you get a better idea of how to find your way. But you as a postdoctoral researcher, it was a different experience. Again, collaborating with some of the professors at Harvard, and again other postdocs and fellow students gave you it allowed you to grow, I think. And I enjoyed the urban setting of Harvard
Mm.
compared to the more suburban setting of Princeton. And so at the personal level, I mean, I used to like watching, I still do, watching a lot of movies from around the world. And there were the Harvard Film Archive used to have
Mm.
fantastic screenings, which I used to go, I mean, almost 3 movies a week or something. And it was great in some ways. The feeling of it was a little more like being in India after growing up in a city like Calcutta.
Mm.
Much of the US seems a little too sort of thinly populated. So that was good. And yeah, so I spent, I think, a very fruitful decade in the US before moving back to India.
Sure.
Yeah.
Sure.
And then you become a faculty member, and that you transition into a different role again,
Mm.
where now you have responsibilities to other students, to other your colleagues, and to an institution, etc. So that's another process of growing and learning.
Absolutely. Absolutely, Rajesh. So, was there a moment or were there moments, a paper or a professor, a conversation that made you feel, yes, this is exactly what I was meant to do? Any such moments you can recall?
Yeah, I mean, so that's one lives for moments like that in the life of a scientist. I think when there is an aha, or you might call it some kind of a epiphany, which makes you feel, yes, I have been lucky to have been sort of to have had this thought that perhaps no one else has had, and which means something, which is something very true about the universe, and which is something very deep and meaningful. I mean, I think the first time I really had a very striking thought like that was in 1998 when I was at Harvard as a postdoc, and I did some of that work with Cumrun Vafa that you mentioned. I think it was. That I think there was a particular moment when many things fell in place, and it was quite amazing. And I think I still have a fairly vivid recollection of that. But there have been other such moments after that too. But that was the first, and that makes it special. And But that's what makes the life of a scientist worthwhile, when you feel some pieces of a jigsaw puzzle have kind of fallen together.
Sure. So there are a lot of fans for you. I can actually see that. I go through your post as well. They might be more interested in the Gopakumar-Vafa duality and the Gopakumar-Vafa invariance, Rajesh. Anything more you can actually share? It's quite exciting because it's there in the international physics literature on your name.
It's a bit challenging to try to explain it in any sense. At least the duality which I think was what I was alluding to earlier is a connection between two apparently very different topics or areas within string theory, quantum field theory, the theoretical physics domains, which is a particular example of something that people had been trying to develop a general connection between what are called quantum field theories or gauge theories, which describe some of our fundamental interactions, and a theory of quantum gravity as described by strings. And one of my classmates, Juan Maldacena, had made an amazing conjecture connecting these things based on various consistency arguments in string theory, and shown that this statement is very powerful and actually can be realized in certain cases. And the duality that you mentioned is a particular instance of this in a very concrete, in some ways a toy model, but the advantage or the beauty of it is that it's very explicit, and you can actually calculate everything right completely, and you can see that these two very different things, they just match, they just agree in a miraculous way. It's kind of sometimes that's the time when you sense that mathematics is the language of the universe, and mathematics through the mathematics you see exactly how some of these things are connected to each other. So that's maybe a rough picture of the connection.
Sure, Rajesh. I would like to bring in a new theme on the inner life of a theoretical physicist, Rajesh, because we got a lot of parent students as the audience as such. So a couple of questions are, string theory has no lab, no experiment, no immediate measurable outcome. How do you sustain conviction in work that may not be validated in your lifetime? What keeps you going on a slow day?
Yeah. I think we are. It is true that the experimental validation is the ultimate confirmation of the theory. String theory took upon itself the challenge of describing or trying to describe the phenomena in physical phenomena in a domain which is at the moment very hard to access experimentally. Right. This is the domain where quantum effects in gravity become very important. There are two places in the universe where they definitely would play a strong role. There might be many others, but one is at the Big Bang, at the beginning of the universe, and the other is in the interior of black holes. it is, and so you do need a theory of quantum gravity to describe some of the puzzles that the current theories are incapable of resolving. Einstein's theory of gravity or quantum field theories, which is the most evolved framework of quantum mechanics, that these two theories or frameworks are incapable of capturing what happens at the Big Bang or in the deep interior of black holes. And you need something like string theory. String theory may or may not be, if you want to be perfectly agnostic, it may or may not be the complete description. But I think if you ask individuals in working in string theory, they find it internally very compelling as the description that would make sense theoretically, and the theorists have a lot of criteria by which they can assess for themselves if they are on the right track or not. You develop those criteria as you grow as a theorist, because when you don't have immediate access to experiment, you have to make sure that the theory hangs together in a way which is perfectly consistent, and that's not very easy to achieve, and it's not very obvious that it would happen. Any old theory anything that you might just cook up as a fantasy will not be consistent with things that you know about gravity or things that you know about quantum mechanics, and which we know have been tested experimentally. So Einstein's theory of quantum mechanics have been tested very well, but you don't want to kind of you don't want to lose that, and so you need to have something that can recover those results, but also say more. And in some sense, I say often that string theory is theoretically falsifiable. In particular, when I mentioned earlier about this connection between gauge theories and string theories, these are very different topics, and in some particular limit, the gauge theories can be described by gravity is one of the surprising consequences of this connection. And now gravity was studied by Einstein. Has been studied since then very much. And similarly, gauge theories were studied for describing the strong interactions, the weak interactions, electromagnetism. But that they have this unsuspected relation between them, it was something which wasn't at all obvious to people. It was a very surprising prediction, and and people have verified this in many contexts, including in the particular toy example that I mentioned, that we studied, that there is this remarkable connection. So there was no reason to have such a connection, and so it could have been falsified. It's somehow the internal consistency of the theory demanded this relation, and it's telling us that there is more. And ever since, I think, in my personal work also, I feel I have uncovered more of this, which need more of these connections, which need not have been true at all. And so you feel that you are on the right track. And so these criteria that you have to assess, I think, if I felt that, no, this is not really working out, you have to have a certain rigor of and sort of a self criticism to be able to achieve that kind of assessment. But I think most people who work are constantly questioning to themselves, is this right? Could this be right? They're kind of pushing it, and it's always turned out to work. And so it makes you kind of it's very difficult to explain that to someone who is not been sort of not gone through that through the details of these things, but it's a very compelling feeling. So that's what keeps you going, that you're uncovering something very deep about some of the theoretical frameworks that describe nature. And these are very powerful frameworks. Quantum field theory and Einstein's theory are the two pillars of 20th century theoretical physics. So you're discovering new things about them through string theory.
Absolutely, Rajesh. Thank you so much. Couple of questions also on what science actually teaches you. Beyond physics specifically, Rajesh, what does training in theoretical science teach a person about how to think? Now, what habits of mind does it build that engineering or medicine doesn't really necessarily develop? Adding to that, many of the students listening chose engineering under pressure and are now mid-career. So, is it too late for them to reconnect with the scientific curiosity they left behind, and how?
Thanks for asking that, because that's something I feel is often discounted, that physics, the study of physics or mathematics or any of the fundamental sciences teaches you a certain way of looking at the world and analyzing it in terms of it teaches you, firstly, a rigor of thinking, that when you study something like quantum mechanics, you see that it's not just something that is just explaining how some atom behaves or radiates, or it's not a collection of facts. It's a theory is more than a collection of facts. It's a logical interdependence of concepts, and how they kind of together fit into a structure like a building. As I think a famous mathematician said, a theory or a subject is no more a collection of facts than a building is a collection of bricks. So you have to there is a structure, an architecture of a theory that gives you a different appreciation of what it means to understand something. You understand it conceptually at a level which is not at the level of kind of just memorizing something, or sort of just repeating something. You've kind of internalized a certain understanding, even even if you're not doing research, even if you've done a master's or a BSc, the much abused BSc in your title. I mean, so even if you're doing that, I think you get exposed to that way of thinking, which also encourages you to think in terms of first principles. When you analyze a problem, if you are confused or not sure what is happening, you dig deeper until you get to the bottom of it. You get to the basic principles, and then try to analyze it with the least amount of assumptions, the least amount of you make hypotheses, but you're always aware that these are hypotheses, these are conditional. So you achieve a certain awareness of the nature of problem solving, which I think is very sophisticated and very useful in a number of situations, which is why you will find many physicists, including through the 5-year MSc program at IIT Kanpur, who have gone on to become great environmentalists, great people who've been educators. People, in fact, the former director of IIM Bangalore was an MSc 5-year from IIT Kanpur, and I think Anil Agarwal, who started this down to earth environmental thing and brought the attention to people about the pollution and stuff in Delhi, etc., was also from IIT Kanpur. So there have been a number of people, I think, who've who've gone through a kind of a training which enables them to apply it to problems in many other domains. So even if you choose not to go into research later for reasons that I mentioned, that may not be everyone's cup of tea. You can still develop a certain training which enables you to be very productive, very creative. And this is why in the US, certainly, I mean, physics graduates are snapped up by Wall Street and financial firms, and now AI companies. I mean, Anthropic is they're actually some of the founders are former string theorists. So that, and even in DeepMind and other places, there are just tons of former string theorists and others who are pushing the frontiers of AI. So you can be very versatile in your it gives you a lot of versatility. I'm not saying that engineering or medicine doesn't do that. I mean, I'm sure I haven't gone through that. So I'm not sure that engineering or medicine also has, of course, any specialized training allows you, I'm sure, build certain things. Maybe some of them are complementary to what you learn in physics, but yeah, I think, but definitely I know that physics training is very valuable.
Sure, Rajesh. Thanks so much.
And I think there was a second part to your question. I'm sorry, I think I didn't may not have answered it.
Many of the students listening chose engineering under pressure and
Yes.
now quit career. So is it too
Right.
late for them?
No, I don't think so. I think I know many people who did their undergraduate degrees in engineering and then even worked for a little while and then chose to come back to physics. I think, especially, and even at ICTS, we have many students who have come from an engineering stream and decided to do their PhD in physics. And abroad, it is also very common that there are people who have maybe almost no background in whatever they did, but have gone on to do a PhD in physics. Ed Witten, one of the very famous string theorists, legendary string theorist, he did his undergraduate degree. He didn't major in physics at all. He majored in economics and in political science and maybe linguistics or something, and then he decided to shift to physics at some point. And he joined a PhD program. So you have people following different paths, and it's not too late if you're driven by a desire. So it's a question of the drive you have.
Sure, Rajesh. So coming to the science society in the Indian context, we're actually going back. So going back to the question BSc Se Kya Hoga reflects a societal flaw that weakens a country's abilities. Can you unpack that diagnosis? What exactly is the flaw and what does it cost India?
Yeah, so I feel that it has created a kind of a monoculture of thinking that it fosters a certain herd mentality, which I think is which our youth don't deserve to be kind of herded into just a couple of different streams. And when I think there is a vast canvas of possibilities, and I mean, knowing people, I've seen that different people have so many different strengths, and I mean, it's a huge multidimensional space that we all have, and we tend to squash it all down to one JEE or one NEET, and then we then just squash people down on that axis, and then depending on where they are, they just kind of follow that, whether it's a medicine or an engineering, and that's a kind of not doing justice to the human capabilities that these people have intrinsically. And even more so, I mean, it was already true in that era, but I think even more so now. I think children at a very young age are being fed into the coaching industry, and I think it just kind of destroys their individuality, their creativity, their ability to ask questions. There are essentially being trained to run a maze, and that is destroying human capital. It's destroying the ability of our youth to come up with new ideas, new, whether it be I'm not just saying in science, even in engineering or
Mm.
medicine or other things, we become followers because we are not we from an early age we are kind of being herded in a certain direction, and that is not that's a disservice to the enormous human talent that is there in all of us, I think, and in India especially, where a lot of people have get exposed to sciences and these things, but then they are forced due to family pressure, and our capabilities in the sciences are much weaker than they should be. India has, I think the figure was something like 25 researchers per 100,000 of our population, whereas China has 200 and the US has something like 600. So you can see the fraction per 100,000. So we are not talking about absolute numbers. We are just talking about the fraction. And that is, I think, is makes us weak as a country, because we don't have then the number of people needed to come up with those fundamental science breakthroughs which are at the foundation of all our modern technology.
Yeah.
People do not realize that maybe 35 to 50% of the US GDP is built on quantum mechanics. I mean, it's built on the laws of quantum mechanics. If people around 1925 or so had not figured out those laws of quantum mechanics, none of this, you and me talking over this, these media through fiber optic cables with touch screens and everything, all of which are harnessing the miracles of quantum mechanics at the atomic level, and through semiconductors and chips and whatnot, and everything that has developed and will continue to develop. It's not like that's over. I
Mm.
mean, quantum sciences are, as you know, even maybe quantum computing is something people have heard of, but quantum sciences are in a big sense. I mean, people are, and I think there will be enormously new technologies in the quantum sciences and quantum sensors and quantum materials of new and unusual kinds. And these are all being developed through breakthroughs at the fundamental science level. And we don't have adequate capability in our country. So it's a weakness. So that's the sense of the statement I was trying to make.
A couple of questions as well in this particular science society Indian context, Rajesh. Now, all of us know that India produces extraordinary JEE toppers, and how many do you think have quietly surrendered their true calling to an engineering stream because of family or societal pressure? And what might we do differently? I think you touched upon it. Secondly, string theory and fundamental theoretical physics have no immediate utility in the conventional sense. How do you make the case for their value to a parent or a policymaker who asks, what is the use of this?
Right. So again, through the JEE, I don't know. I mean, many people, of course, some fraction of the people who have gone through the IITs and so on have gone into academics in different streams, and I think many of them uh, uh, have done very well in the sciences. Sometimes they may have done very well in the JEE, but even many others who were not necessarily, again, I think the rank and other things are not the greatest determiner of success in research. So there are people, I think, who've done extraordinarily well. I think many people who actually went into computer science, but who were secretly very uh, good and enjoyed mathematics, kind of often found a way to to go into the more mathematical end of computer science and theoretical computer science and effectively become mathematicians. I think I've known several people who have done that. But again, many of them are outside India, which that has always been the case with many of the graduates from the IITs. But yeah, so I think perhaps if there was perhaps more people could have joined some of the science streams and also contributed to it. But I don't know. One positive thing that has happened since the time I was a student are these IISERs, IISCRs, which offer undergraduate programs very much like IITs for the basic sciences. And there are 7 of them, and they are excellent places. They have very good instructors, very modern campuses, and the courses you get exposed to, and bright young faculty who have been trained very well. So there are now many more places in India, I must say, where you can do. It's not just the IITs. So the IISERs, the Chennai Mathematics Institute, the Indian Institute of Science itself has a brilliant undergraduate science program. So there are many, many options now for people, and I think more people are taking those up. It's not just the IIT that used to be. And in fact, I think people who join IITs now are mostly they join it and very soon start. It's more into the startup
Yeah.
economy and entrepreneurial thing, which is fine. And I think there should be people doing that. But if you want to do the sciences, it's not just the IITs. There are many other places. So that's one thing I wanted to say. And your second question about theoretical physics, particularly maybe string theory, so one could have said the same thing about quantum mechanics in the 1920s, because you're trying to understand the behavior of atoms, and which are anyways things which are so far removed, at least at that time, from our experience or anything. It's just I mean, it's what will it all be good for? And people said that earlier about electricity and magnetism. And there's a famous story, I think, of a British prime minister or a minister coming to James Faraday's lab and asking, he was showing him all these experiments with magnets and other things, and then asked Faraday, what's it good for? And Faraday supposedly replied, one day, dear sir, you will be taxing this. And then of course electromagnetism and everything changed that era. And then similarly, quantum mechanics defined another era, which led to another technological explosion. So we forget these things. We forget where they come from. That at the time when they were developed, they were considered very esoteric and very far removed. And that's the failure just of our imagination. I mean, I think that we are unable to see where things can lead to, but accumulated over generations. And it's not that the founders of quantum mechanics were the ones who built the chips or the lasers or the fiber optics and whatever that we use, or the atomic clocks. They just were, in a sense, driven by curiosity, the idea that what are atoms really made of. And there was definitely a puzzle at that time, somewhat like the puzzles I mentioned about the Big Bang and black holes. The puzzle was, why are atoms stable? In fact, the theories of Maxwell and Faraday predicted that atoms should not exist. They should not be stable if they are built of electrons and protons. But what accounts for the stability of atoms? So in trying to answer that, they realized that the world is inherently described by a quantum framework, and that changed things. And one doesn't always see that, and it's not. I think even individual physicists, however brilliant they are, cannot foresee those changes. But it has always proven to be the case that that knowledge that one generates about the universe, about the world, then it could be not just about the physical universe, it's about the space of mathematical ideas, the space of the biological universe around us. All of these knowledge, just for the sake of knowledge and understanding and curiosity, play a role late in some unexpected way. So this has continued to be the case. And in fact, the Institute for Advanced Study at Princeton, which you mentioned, which had Einstein in his latter part of his life, the founder of that, who was not a scientist but an educationist, had written an essay called The Usefulness of Useless Knowledge. So giving in 1925, actually, or so, before quantum mechanics, the reason why seemingly useless knowledge should be supported. So that it's that vision. If you have that vision that it's not something that you might see tomorrow or later. Von Neumann at the Institute then built a computer just because he felt, yeah, it would be great to try to build a mechanical object that could do complex calculations. And it was a very clunky, big machine before chips or anything, just built out of diodes and whatnot. And but that evolved later and it was based on ideas by Turing, which was based on pure mathematical ideas of Gödel, etc. So the interconnectedness of the space of ideas is just enormous, and that I think it's almost like a article of faith that it will produce wonderful things. And just to bring it to a little more concrete level, at the current moment, also some of the ideas in string theory one can see some of them perhaps being connected in unexpected ways to other things, like string theory and the physics of black holes has brought in ideas of quantum information very much, which is very central to our ideas of quantum computing and how best one can harness quantum information, how best one can correct for errors in quantum computing. So some of these ideas coming from a very different source in studying black holes and the so-called information paradox of Hawking can perhaps shed light on things to do with quantum information. Similarly, things that many physicists are discovering about the states of matter are leading to new materials, which will, I think, change a lot of things because these are very remarkable new materials not found in nature, but you can now fabricate in the lab based on, again, predictions from theory. And so I think that just will continue. And so, but that, in a sense, it's a kind of a byproduct of the production of knowledge. And I think in India, we always had that we had a tradition of valuing knowledge when people when for its own sake. I mean, it was because people were interested in understanding things around them, understanding the stars, the behavior of planets, and the behavior of and understanding mathematics. And someone like Ramanujan, who was just come as a kind of exemplifies that pure thought in mathematics, was exploring things which from just the drive of understanding mathematics and not about whether it will be useful in something or not. But it turns out that many things that Ramanujan did are useful now in many other ways, in cryptography or in many other areas. It's I think we should be, because our ability to see ahead is so limited, we should be instead just seeing how valuable is the knowledge that is being produced and have the space to create that knowledge.
Absolutely, Rajesh. Lovely. It's already 10:33, Rajesh.
Sorry, yeah.
No. I'm loving it. Just one or two more questions. I think
Sure.
building ICTS-TIFR. Couple of questions. You've been building, ICTS-TIFR as a vibrant center for theoretical sciences since 2015. What's your founding vision and what has been the most satisfying milestone so far? That's one. What does ICTS offer a young student of theoretical physics or mathematics today that was not available to you in 1987? And one last one there is what does India still need to build in order for its theoretical science ecosystem to reach its full potential? What are the gaps? These three questions I have.
Okay, I'll try to be short. ICTS was built on the vision of trying to actually be a hub for science, which is not just the researchers at ICTS. We do have faculty, we have PhD students, and we have postdoctoral researchers, but we also have a large number of visitors who come for the workshops and programs that we organize. And in that sense, actually, my predecessor, Spenta Vadia, who founded the institute, was influenced also by places in the US, like the Kavli Institute for Theoretical Physics in Santa Barbara, and many other places, which have very successfully brought researchers together for workshops, which has built new collaborations. And that's how, in a sense, new ideas are born when people interact different across disciplines, within disciplines, but bringing people together in a structured way through various programs that we organize. That was one of the unique features of ICTS. And I think in the last 10 years, the number of activities we've organized has just mushroomed like crazy. I mean, we now have about 3,000 visitors coming through ICTS every year, and half of them are PhD students and master's students in Indian institutions. And a good about 25 to 30% are participants from abroad, from outside India. So it's an international center, and it sort of brings together the best globally with the Indian communities in different areas to push ahead to in frontier areas where India is perhaps lacking in critical numbers, and to grow those numbers. This capacity building that I was saying, why we have 25 researchers per 100,000 people, which is very suboptimal. So you want to be able to create larger numbers of people in various areas, especially the frontier areas. So that's been one of the mandates of ICTS. And your second question was about about what ICTS provides, which for a young scientist. So of course we don't have an undergraduate program, though we do take in some few undergraduate students for a year-long master's, not a master's, a year-long research project. So they can come and spend a year in their final year, or maybe people who take a break year after their undergraduate degree before going to a PhD, they can spend a year doing a long-term project, which can actually be an introduction to research even before you go to a PhD. So it makes that transition that I mentioned right at the beginning from being a student to a researcher perhaps a little easier through doing a kind of a project under a mentorship of faculty. And that is something I think that has worked quite well, but the numbers are small. So that's an opportunity that we offer to undergraduates. There's, of course, our PhD program, which we have about 120 students. And so that's something which is, I think, very competitive, very people I think we are very lucky to have some very good students join us through that PhD program, and similarly the postdoctoral program. So it gives, I think, a chance for people to to see that in India you can do world-class research. That's ultimately, in a sense, one of the things I would like to see, that we are pushing the boundaries of the subject. We are not just doing incremental research. We are not just following others and just doing a little bit more, but we are trying to push new directions, open new doors in research through the work at ICTS, and have that global visibility as a result, which I think is happening, beginning to happen. A lot of we have, I think, an excellent faculty. I'm very proud of all the young faculty, many of the senior people who mentor them, are mentors also. And I think it creates a certain buzz. And I think we want to have that buzz at ICTS, where when you come there, you feel, yeah, this is a place where ideas are in the air and you just have to pluck them from the air, and you have to just start talking, thinking, discussing, and it will stimulate you and it will stimulate ideas. So it's an intangible thing that we are hoping to create at ICTS. I think we have some measure getting there, but there's always a long way to go.
Sure.
And there was a third question. I think I missed.
This was on what does India still need to build in order for its theoretical science ecosystem to reach its full potential?
Yeah. So firstly, I think it's again numbers. At some level, you can't beat numbers, and you need. I mean, China, Japan, Europe, US, and so on. I think just in terms of resources and people, I think we are much lagging in terms of those numbers, and we have to go there. We have to move in that direction. We have to create many ICTSs, many places where students feel that there's a home for intellectual sort of create. I mean, where there's an intellectual buzz which you can kind of be part of, and which brings out the best in you. An institution should be an entity that takes the individuals and gets something bigger than the sum of all the individuals out. It shouldn't be the other way around, which unfortunately many institutions do tend to become, that it's the less than the sum of its parts. And an institution shouldn't definitely be oppressive and crushing creativity and kind of bogging people down. People should be an institution should liberate people to think them in their kind of most creative way. And we need many such institutions in India, I think, to be able to unleash that potential.
Sure. Sure, Rajesh. One final question, if you're okay.
Sure.
It's for the next generation. So again, 2, 3 questions, but I'll summarize it in one. If a student who's topped JEE this year writes to you saying they want to pursue a BSc in physics, what would you tell them honestly, including the hard parts? What is one mental model or habit or piece of advice? I think you actually gave me more, but in case you have anything else, if you can add. So one mental model, habit, or piece of advice that has served you most consistently across your research career. And any one question you wish someone had asked you early in your career that you would have liked me to ask you during this conversation. So these 3 questions.
Okay, so of course, I mean, anyone who wants to do physics, whether they've topped the JEE or not, I think I'm always I encourage them, because I think it's very important that they follow it. And I think it's no better or no worse than going, I mean, at the very least, at the very worst, you may find, okay, research, you're not cut out for it, but I mean, but still, as we discussed a bit earlier, the BSc or the science training will be very valuable. It will be a lifelong training for you. After going through that, you would be able to view the world, whatever problems and whatever you choose to do, it will help you. So it's not going to be lost. It's not going to be the thing. And of course, at best, if you are really feel you can go in for a life of physics, including all the hard parts that I mentioned earlier, which I will definitely mention. One shouldn't just have a too a rose-tinted view of things, and it's not the same as giving exams. I like to keep saying that that's maybe one skill, but it's another skill to do research. And so I would definitely advise that about a model or this thing. I think that what has served me always is going to first principles. I think I mentioned going back to first principles and understanding what those principles are, kind of have a layered understanding of things. And when you feel puzzled or are faced with a problem, the best way to analyze it is to try digging back further and further till you get to the basic principles, and then try to see what gives. So that's, I think, something has served me well. And finally, about the question someone might have asked me, I wasn't quite sure I understood that. I mean, you were wondering if there would have been a question you wish someone had asked me. Well, I mean, I wish. I think. I don't have a very this thing, but I wish people would ask me about what I think you did about what is it that really makes the life of science very valuable. What is it that I mean it? I think it's the sort of the converse or the obverse of BSc se kya hoga. It's like what is it that you? I mean, what is the new world that opens out to you when you are in the science, when you go into a life of science? And I think there are so many dimensions there which we touched upon in our conversation, which I think await someone who is open to the idea. So BSc से बहुत कुछ होगा.
Thank you so much, Ryan. I think one of the best interviews that I've had the last 3 years. I've interviewed almost around 75 people the last 3 years, a lot of corporate leaders. But I think the way you actually articulated would actually help build India, Rajesh. So thanks so much for coming in. Just as a summary, I think we actually covered the moment of choice. We actually took us back to 1987 in terms of how you actually chose your learning in physics and the questions that people actually asked at that point of time, and your learning journey from IIT Kanpur, the physics program especially, and to Princeton PhD, to Harvard research. You actually gave a lot of insights over there. We touched upon the science society in Indian context, and you gave a lot of insights for the students and parents. We also touched on how your vision of building ICTS and TFIR kind of activities you're actually involved in, and your advice for the next generation. And I also pitched in, questions in terms of what science actually teaches you, and beyond physics specifically, and the Indian science ecosystem. One thing on the honest assessment, maybe I'll pull you in for another enlightening session. You also looked at the inner life of a theoretical physicist as such. So in summary, thanks a lot for your time. It's all kind of late, so sorry for that. But I really loved the way you actually articulated the vision. And I'm very, very sure that all of your advice is well taken, and the parents and students should definitely listen to this particular podcast. Anything else you want to add before we close, Rajesh?
No, as I think we've pretty much touched on many things. And just to your audience, I think the very fact that you're watching this program or podcast means that there is something within you which really feels that you should maybe tread a different path. And so by all means, do that.
Sure, Rajesh. It's been a privilege hosting you. Thanks so much for accepting and coming, Rajesh. Thanks so much.
You're welcome. Thank you very much, and all the best with the podcast.
Thank you so much, Rajesh.
Thank you.